Hi, I'm Yati, and the subject of my talk is trying to run Perl on Android. Now, before I start, I'm not telling you to do this, or this is not this is not something that you should do. It's more like an effort to push the compiler to its limits and to try runtime, which runs Java but is not quite Java. Like it's not Oracle Java, it's not Java SE. So yeah, why would I do that? Why would we do that? It's like I said, it's a real test for the compiler. You push the compiler to its limits. It's a very different runtime. You have some APIs that come only in Android, which are not there in SE, and there are some SE APIs which are not there in Android, so they are and also the architectures that typically these platforms target are different. A lot of CPAN modules, especially in the field of computational biology, where Perl is still being used, could be potentially used in educational apps on Android. And that's, a motivation. How would we do this? The reason why I'm at number 3 today is because I wanted Flavio to explain how the compiler works. It's essentially using the DSL that he just showed you, which means nothing to Perl but means a lot to Perlito, to generate Java classes from within Perl. So we'll walk through an example. This is a very simple sub which doubles things. In Perl, basically, you can treat the second or first argument as a string as well as a number, and depending on what operation you do on it, Perl will coerce it into the right value. So as you can see, twice of 2 is the number 4, twice of 2 the string is 2 concatenated to itself. The first step towards using this function in an Android app is the specification of this interface which maps a string to a string. This is not the planned way. I mean, this is not how it will be working in future. We are working on a way to get rid of this requirement of creating this interface. Well, this is going to go away at some point. The real first step then would be to create the definition of the target Java class within Perl. If you remember from Flavio's talk, this means this is valid Perl syntax, but Perl will do nothing because it's just a hash within a it doesn't mean anything to Perl. The first line basically says that a generated Java class on Android should belong to that package. Second line says we use Java lang string. The third line, we are importing the interface that we just defined in Java into Perl, and the rest is the specification of our class, which I choose to call camel. I say it implements operation, the interface that we just defined and imported in Perl. It is a public class. The Java inline bit I'll get to later. It's required here. Then we say this class, the implementation, the body should contain these methods keyed by the name. We only implement one, only to conform to the operation interface, which has just one method called perform. So we implement just that to meet the interface. And we say it is a public method that takes a string, returns a string, and the most important bit, when called, we'll call the Perl function main twice the sub that we just defined in the main namespace. To give you a bit of context, this is the Android project structure, part of it. We have parallel Java and Perl directories at the same level. The Java thing is generated by Android Studio by default. We created the Perl directory and added the script, our script, which contains the functions and the code that you just saw. We call it camel.perl. And Perlito will use this to generate camel.java, which contains the generated code and the runtime, the Perl runtime. How do we do this? Well, we can invoke the Perlito file compiler like you saw on the camel.perl file. Target is Java, and we redirect the output to the desired file. Now this can get cumbersome with multiple builds, so I created a simple Gradle task. It's hard coded at the moment, but it works. What it does is before every build cycle in Android Studio, it creates the required Java file so that the Java compile phase sees all the files when it's supposed to see. Then the code that uses our generated class. This is plain Java code. The important bit is here we create an object of type operation and instantiate the camel type, which is basically the generated Java class that we generated from the camel package. And we do our thing. This is UI stuff, and the last line, the last significant line calls perform on this object. Now, if you remember, we just specified perform to be just a proxy to our Perl subroutine. So in the end, what we are saying is call that subroutine and get the input from user and show the output. I can show you the images of what this thing looks like. I have to get out of full screen first. Yeah. So this is the app as it looks like, and you put a number double, you see the number doubled, and you put a string and you double the string, it doubles the string. I was here. No, I was here. So yeah, that's that. This code is responsible for doing what you just saw. This is the full camel.pl file for context. Contains the Java class declaration and our subroutine in a separate package. Now the generated code. Now when Perlito Java compiler sees the declaration in Perl of the Java class, this is what it generates. It's essentially a line-to-line, line-by-line translation of the Perl configuration, so to say, into Java. But remember the Java inline bit that I skipped last time? It basically just injects some piece of Java code which you provide inline into the class being generated. Now this is needed because as the compiler works today, it's essentially a full Perl runtime within Java. So you need to initialize the runtime once. It needs to create closures and it needs to go through what variables are closed over and all that stuff. And we do that in a static block. So that's why at this point this is required. If you look at the main code, what it does is it says perform, all it does is it calls the function call twice. Main.apply essentially takes a string argument, the name of the function, and calls it with the rest of the arguments. This is our subroutine translated to Java. There's a lot going on, but if you look through the ugly symbols, it's essentially again a line-to-line translation. This shift you have here a temporary a randomly generated variable .set list.shift and so on. A thing to note is here in the if condition in the Perl code, we are doing if 0 plus thing equals thing to check if it's a number. You will see that Perlito has automatically created a constant for that, 0 there, and it's calling a function on it, a method on it, and then it's calling *ec on it, and it's converting it to bool, which is needed in Java because up till before to bool, it's a Perlito object. Only when you call toBool on it does it become a native Java Boolean. Another thing to notice here is that we have an early return here, but you don't see an early return here. Now it's funny. The early return should have been here, but instead we see a perlop statement, perlop ret. Well, you return the multiplication of 2 and the argument. What this interlude does is it throws an exception and which is caught outside and returns early. So that's how early returns. Well, this is implemented in this case. I thought that was interesting. To recapitulate, to have your Perl code be called by Java on Android, you write your class definition, which is generally applicable to any Perl to Java job. Generate the classes using Perlito PL compiler, target Java. Main.init is required somewhere to initialize the runtime, and then call the exported methods. The wish list. Flavio briefly mentioned how we are currently treating excess, modules that use excess. We basically have shadow modules which act as a proxy, and they're implemented in Java rather than C. I think this is less than ideal, and what we should be doing is have JNI wrappers around excess code being generated automatically, which can then be used in Java. I have no idea how this can be done, but it's a target worth pursuing. Another thing that the compiler currently does is the runtime and all the user classes are dumped into one huge Java file, which is not ideal. Again, we would like to split the runtime and the user classes into separate files, as is idiomatic in Java. Android specific targeting. I found yesterday that a change in the Java compiler, because it targets 1.7, broke Android, because that class Java NIO files is not present on Android. Android is a very different runtime, and we really need a separate target of the form Android version instead of C Java. But like I said in the beginning, this is right now more of a test for the compiler rather than a full-blown Android framework cross-compiler. So maybe later we will have that. Now, are there any questions?
I'm not sure if I understood that correctly, but
yep.
If I want to proxy a function, do I have to do that for all my methods that my class has on its interface that I want to expose?
So you mean, if I get your question correctly, you have a bunch of Perl functions which you want to expose to Java.
Yes.
Would you have to create a proxy for each?
Yes.
Well, in this example, I chose to export a class as such. I chose to put a method in a class. You don't necessarily have to do it. You don't necessarily have to proxy all of your functions, but if you want the functionality from them to be used directly by Java from a class, then yes, you have to write that configuration.
Can you go back to the compiled wrapper?
Yeah.
No, the previous one. Yeah. When this is generated automatically for you. So main apply any function works. So this is apply will then look up the function in the namespaces, right. And if it's there, it will return the closure, which will then be called with a list of parameters.
So if you are okay writing this yourself, yeah, you don't have to create the proxies. Any more questions? No? Okay.